Hey everybody, this will be a tech deep dive video into our product detail page. Uh, we're going to take it all the way from the top, go over the front end technology that's being used, some techniques and approaches we're using, and ultimately get all the way to the back end for how the data is loaded. So this one might be a little bit long, but you can um, seek through to get to the section that's most relevant. Starting at the top, our website is a Next.js website hosted on Vercel, and we're using as many of the value add scaling features that we can get on that platform, which we'll go into in detail. For styling, we're using Tailwind CSS, primarily having built our own component library to make some of these layouts easy to play around with and swap in. On the product detail page, we're already using some of the Next.js features like layouts versus pages. So most relevantly, this navigation bar here at the very top of the page, also this call to action here, those are all rendered in the layout, which means that these do not re-render as you navigate throughout the site. So only the page content here is being swapped out. Coming down into the core part of the page in terms of the information being displayed, one thing stands out, which is that the vast majority of this information is static. So the title, the price, the description, the brand, the pictures, all this information is static and specifically doesn't vary at request time or by user. And so there is an opportunity, at least there seems to be an opportunity to cache this information. And evenly statically render the page. So you could cache the data for this product in something like Redis, which we do. But on the front end, you could actually feels like you could render this entire page and serve it really cheaply without having to render it on the server, thus increasing server costs, or rendering it on the client, thus increasing page load time. The problem is that while it is largely static, it's not 100% static. There are a few pieces of dynamic information. So there's some user state specific piece of information. Are you logged in? Have you liked this product? And yeah, if you've recommended it, you can see that indication that you've done something here as well. In addition, there's even just more data that varies much more quickly or expires much more quickly than some of this product metadata, which is, yeah, the amount of activity, the comments, how many times it's been recommended. So we can't just, it's not a blog post where we can completely statically render the page and be done. We need to be able to refresh different pieces of the data at different cadences. And so some of that is going to be at request time. So yeah, the user specific stuff like how many recs, you can imagine some kind of external cache for validation that triggers a regeneration of the page. But for the user specific stuff, we have to do that at request time. We need to look at the cookies to see, are you logged in or not, and use that to make this determination. So this is all set up for one of the main reasons I was excited to use Next.js, which is that they're pushing really hard in this specific area, specifically with technology of partial pre-rendering. And so what partial pre-rendering allows you to do is basically fence using suspense boundaries components or chunks of the page that you expect to be dynamic, that need request level context in order to populate the values. So exactly like whether this should be filled in because it's hearted, exactly like this whether you are logged in or not. Um, these are the kinds of things that we can say, hey, ignore this when statically rendering. Actually, better yet, render a placeholder when statically rendering and include that in a complete static version of this page that can be cheaply rendered, cheaply generated, and then cheaply served to incoming users. And then we will hydrate and do the server needed processes to populate the rest of these values at request. But that's going to be way less load on the server because it's a lot less that needs to be done per request. So that is actually being used on this page. So we were early to the partial pre-rendering party, and this was definitely a good use case for the page. We had a company objective to really focus on the SEO ability of this page, which both means server rendering as much as possible, but it also means loading as quickly as possible so that we perform well on all the Google metrics. So one of the big pushes was to get this into the web page test org 90s across the board, and that definitely helped us do less on the client and helped time to first byte. Also helped our largest contentful paint getting that below 2.5 seconds. So that's a little deep dive there. To go into a little bit more detail, for comments, we're using an external service, Hivor, which has been an amazing choice for us because there's a lot, any mutation where you're taking in data from users requires a big build. And so this allowed us to test this feature out quickly. Also, we have some nice value add features like we can moderate these comments ourselves. They have some AI tools that help do that automatically, but it allows us to feature certain comments for hot products or mark things as spam, etc. Anytime you've got user generated content, it's good to think about things like that. And then there was pretty good styling support where we were able to build out our own style sheets to make this feel pretty native to the rest of our design. A couple other things to call out on the front end are just the technology we're using for rendering some of these modals. So you can see for activity and for recommendations, we have just what appears to be a pretty classic modal layout. What's cool here is we're again digging into the Next.js bag, and these are using parallel routes where this is not simply a client-only modal that pops over the screen. In fact, we're actually using the Next.js router. We're routing to a different page, a subpage you can see in the top. We're now /comments. Whereas if I go back, we actually are using the back button. And when I click Rex here, we are also able to load, we're pushing into the recommendations route. So a couple nice elements here. One is you could actually share like a link to this information and it would preserve that. Actually, would render a specific version of the page around this content. Also, just people, maybe you've had this experience, people hit the back button, especially on mobile. You might swipe back instead of hit the X, and re-implementing all of the expected UX for that when it's completely client side is really tough, and you end up maybe missing an edge case that when they meant to go back and just close the modal and get back to this page, they actually go back to the previous page. And so we're able to use like the standard browser features in order to support that. But the other really nice piece, what I would say, is that it actually makes the DevX much better. You're able to write the code for this completely as its own separate page. So you can implement this modal without thinking about the page behind it at all. So you're able to just think like, okay, I need to render a modal. It's going to add some gray transparency to the background. I'm going to have this data. Here's how I'm going to fetch the data. By the way, the data can all be fetched server side, which you might have to think a lot about if you're going to implement it client side. Now you need to go look at where this page is fetching its data and add some more server side fetches that you have to plumb down into the client side component here, which can be a pain to get through. But here we can just start our page. We're on the server using React server components. Let's fetch our data, make our modal. And it promotes reuse because I can have a link to a modal in many different places. And I don't have to worry about fetching the data for that modal on each specific page and passing it down. And so, allows you to really just focus on what you're trying to accomplish here. And then again, on the client side, the benefit, or pardon, not client side, but just on the when developing this page, the benefit to this, what this looks like in code is just a link. You just link to the, in this case, comments route. And just consider how much simpler that is to drop in a link versus, import the component for the modal, make sure again that it has all the props and data it needs. It can feel way heavier, especially if you're trying to optimize things around data fetching, making sure you have everything you need at that time. It often isn't quite the same as just dropping in like a simple tag to open that up. So we've used that feature really extensively. It has some options where you can see where like on hover, it prefetches so that it still feels responsive. And that's been a pretty good solution for us. Scrolling down, again, just using Suspense heavily here so that we kind of fence off different sections of this below the fold. And we're able to, for example, this is clearly like a login CTA, where if you're already logged in, we wouldn't show this, we'd show something else. So there's some, again, little places where we can, yeah, try and do this in a component level, and definitely evangelizing React Server components here to allow us to think a little bit more independently about these sections, not worrying as much about client server waterfalls, and just, yeah, I have these slices in the page, I can add them independently, they'll load in parallel, and anything below the fold, I'm not worried about when it comes in, as long as it has a decent placeholder. And then, great, so let's kind of start going towards the back end. We kind of covered just the overall front end layout here and some of the tech that we're using. On the backend side, we have a single API endpoint for the vast majority of our requests, which is a GraphQL monolith that we maintain in-house, written in Python, using Ariadne, which has been a nice ASGI GraphQL server. That backend really is kind of the quarterback. Again, being that GraphQL interface, it's translating a lot of kind of business needs from pages like this into a variety of different calls. And so that, for us, is a Cloud SQL Postgres to store any kind of data that's related to users that might mutate and needs to be high availability and low latency. So whether you like something, save it, create an account, create a new list, any of that type of information, upvote something, recommend something, that's all going to be saved in Postgres and loaded from there. And then any static data, like this product metadata and pricing, we save that into a Redis database keyed on essentially the product ID, something equivalent to the URL here. And that's wonderful because it allows us to do a simple key lookup and just get a JSON blob of all of this metadata that's stored there. One benefit of this approach is, while this data is static, quote unquote, it changes slowly. It does change. Prices in particular do change. And so we recrawl and reindex using an in-house web crawler system that we can call in Kubernetes to kind of farm out over a set of machines, and respect rate limits and kind of go slowly and index, just like Google or Bing, many of these brands. And Shopify sets up their websites with a nice sitemap and great robots, very permissive robots txt to support indexing these brands, because of course, from Shopify's perspective and these brands' perspective, they want this content to be as visible to consumers as possible. So wherever they're browsing, they want to make it easy to discover. So we have this crawling infrastructure that runs, and we try to get a refresh on every product, every one of our 700,000 products, in around a week. And so we're running them, periodically, just slowly but surely around the clock. And every day we do a refresh where we will essentially generate a new Redis cache, and then release a new version of the service that points to that new Redis cache, which stores all of the product metadata. And that's really nice because we are able to, you don't have to do any complicated diffing to say, was this Redis updated, removed, changed? You don't have to do anything like that. You also aren't worried about mutating something that's being used in production. You're spinning up a brand new resource that no one's talking to. And then crucially, you're not destroying the old resource immediately. So you can point to the new one. If there's some issue that has happened that escaped the checks, you can always roll back and point to the old one. And then we have a cleanup process that will delete those old Redis caches after a couple of days and after no active services are pointing to them. So that's been a great way for us to have a low latency way to serve this mostly static product metadata with a pretty clean or simple developer experience for how that data can be updated. Coming down into the stack, I think the other interesting thing to talk about here, and maybe an area where the Marmalade PDP, which I mentioned, our SEO objectives, why maybe we had seen this rank well, and where it could be differentiating for users versus just the product detail page on the Shopify store, is this related products section. And so what we're able to do by having products from 10,000 brands is show you other things that you may be interested in based on what you're currently looking at. And so in this case, we've got some other cool, we have a butter dish here, very stylish, and a number of other either kind of either functionally similar or kind of visually similar alternatives that you may want to consider. And so we'll talk about in another video a deep dive into our search stack, but this is utilizing that same core technology where we create a semantic embedding, semantic meaning, meaning that essentially it's storing a representation, a numeric representation of the product, but in a way that you can do math on it in terms of concepts. So it might have an element of it that where all things that are green have certain numbers that are similar, and something that's a butter dish might have other things that are similar, or things that are food related may be similar in other areas. And so it's a very rich, high dimensional vector for us, 1024 dimensions, where yes, certain dimensions may correspond to these different conceptual properties that allow us then to make a statement like things that this is near, and near, just like in, on the XY plane, 2 points can be near each other. Similar concept applies even in these higher dimensions. When things are near, they're similar in some way that would mean something to us, and that's what the semantic embedding connotes. And so a really nice case where we're able to build out a whole other product here, this recommendation system, off of the same core technology that we're using for our search engine. So we take the product and basically say, give me like the 20 nearest neighbors of this product in our 700,000 product catalog. And maybe, yeah, we add a little bit of sauce to make sure that they share some key properties. For instance, if it's like a cat toy that you're seeing here, we have the way to say, show me similar products, but make sure they're for cats. We have a few of these metadata attributes that we encode along with that semantic meaning, which just gives us the best of both worlds. We can make some hard filtering choices, but then also just rely on the AI to find things that are similar. And so that powers this recommendation piece as well. I'll call it here, but this is a deep dive into our product detail page.